So I'm going to take you through each of the problems on the exercises in case you need help on it. So you can use this to help yourself by, if you get stuck, looking at it and figuring out how to do it, or you can use it to hurt yourself by just writing down the answers. But since I can't be there, I'm going to go through this and hopefully this will help. So on number 1, they told us that it says the function g of x is equal to the absolute value of 5x minus 4 is a horizontal blank of the function f of x equals absolute value of x minus 4. So we're starting with f of x equals the absolute value of x minus 4, and we're finishing with the absolute value of 5x minus 4. And they want to know what type of horizontal thing occurred to do this. Well, remember, horizontal just affects the x, and so since the 5 is inside and just affects the x, it's multiplied, so it's either a stretch or a shrink. And then remember, if it's horizontal, it is always the inverse of what it is. So the thing that changed is this went from 1 to 5, and so that was, the number's 5, but remember it's the inverse, and the inverse when it's multiplied would be 1/5. And since 1/5 is less than 1, then this would be a horizontal shrink. So that's number 1. Number 3. So number 3 says write a function g whose graph represents the indicated transformation of the graph of f of x. So in this case, we started with f of x equals x minus 5, and we're moving it 4 units to the left. Now remember, left, the first thing you're always going to ask yourself, is it horizontal or vertical? And left is horizontal. So what I do is, to get my g of x, when I come to x, I put parentheses, x, and remember it's 4 units left, which is a negative 4, but we do the opposite of that, or the inverse of that. So we get x plus 4 minus 5. And then we just simplify this. So 4 minus 5 would be x minus 1, and that would be the answer to number 3. Number 5. It says write a function g whose graph represents the indicated transformation of the graph of f. The equation f of x, so again we write down our starting point, the absolute value of 4x plus 3 plus 2 is translated 2 units down. Well, down is vertical, and remember vertical affects the whole thing, so I just take and I put in parentheses the whole function, and then when it's vertical it is what it says it is, so 2 units down would be a minus 2, and then we simplify. Now remember, you can't do anything to what's inside the absolute value until you know what x is, so that's going to stay the same. And 2 minus 2 is 0, and so I'm done. My g of x would equal the absolute value of 4x plus 3. Number 7. Number 7 says write a function g whose graph represents the indicated transformation of the graph of f of x. So in this one you have a graph, and in this, the graph, if you look at it, some people think it's reflected because the lines are shorter on the left and then shorter on the right, but that's just, remember, the arrow means it goes on forever, and they just have it because they stopped when they got to the edge of the graph. So what happened on this was they took the function, so we started with this function, f of x equals 4 minus the absolute value of x plus 1. And so what happened was they shifted that graph 3 to the right. Well, 3 to the right is, again, you ask yourself, horizontal or vertical? To the right is horizontal, so I'm going to, when I come to x, put parentheses, and then I'm going to move it 3 to the right, and 3 to the right would be minus 3 because we do the inverse, which is the opposite. and then we simplify what's inside. Negative 3 plus 1 is 2. And so it's f of x, or g of x, equals 4 times, or 4 minus the absolute value of x minus 2. Number 9. So number 9, it says, select all the translations of f that result in the graph of g. Well, if you look at that, there are more than one thing because it's just a slide. And so we could move that up 3, so that would be translate f up 3, or we could move it right 3, and so we could check the box right, translate f right 3 units. So the first 2 boxes would be checked, the others would not be. So there's nothing really to show on that one. You just have to look at the graph and tell how it's translated. So let's go to number 11. Number 11 says write a function g whose graph represents a reflection in the x-axis of the graph of f of x. So now remember, the x-axis runs this way, so when we reflect something in the x-axis, that flips it over the x-axis, so that's going up or down, and so that is a vertical reflection. So now remember, we're starting with the function negative 5x plus 2. Vertical affects the whole thing, so we put the whole thing in parentheses. Reflections, remember, are negative signs, so we multiply that by negative, and then we distribute. Negative times negative 5x would be 5x, and negative times a positive 2 would be negative 2, and so we end up with f of x minus 2 is our new function. Number 13, it says write a function g whose graph represents a reflection in the y-axis of the graph of f of x. So our starting point is f of x equals the absolute value of 6x minus 2, and they want us to reflect it in the y-axis. So remember, the y-axis runs vertically, so if I reflect in that, then it's going left to right, so that would be horizontal. So remember, horizontal, we just write it when we come to the x, we put parentheses, negative x minus 2. And so now when we simplify that, 6 times negative x is negative 6x, and then minus 2. So that's number 13. Okay, number 15. Number 15 says write a function g whose graph represents a reflection in the y-axis of the graph of g of x equals f of x equals negative 3. So our starting function is, again, we always start with our starting function, negative 3 plus the absolute value of x minus 11. That's our starting function. And we're going to reflect that in the y-axis. So again, y-axis is reflecting left to right. So now that means it's horizontal. So remember, horizontal just affects the x. So I put parentheses. And then I simplify. So the part outside stays the same. Oops. And so this would be the absolute value of negative x minus 11. Okay? So that's 15. So 17 says write a function g whose graph represents a vertical stretch by a factor of 5. And our original function is f of x equals x plus 2. And so we're doing a vertical stretch. So remember, vertical affects the whole thing. So I put the whole thing in parentheses. Stretches and shrinks are multiplication. So we're doing a stretch by a factor of 5. So we multiply by 5. To simplify this, you just distribute it. So 5x plus 10. 19 says write a function g whose graph represents a horizontal shrink by a factor of 1/2 of the graph of f of x. So our starting point is, now the horizontal is the part that causes most people trouble. It's asking us to do a horizontal shrink of 1/2. So remember, horizontal affects just the x. So when I come to the x, I put parentheses. And when you do horizontal, remember, shrinks and stretches are multiplication. It's always the inverse. Now remember, inverse with a fraction, when you're multiplying, is the reciprocal. So we do the reciprocal of 1/2, which would be 2. And 2 times 2x would be 4x plus 4, and we're done. So 21 is a little bit different. They give you a graph, and when you look at this graph, the vertex is at 4, 2, and the graph opens down like this. And then the new graph, the blue graph, starts at 4, 1, and it gets wider. So they're telling you, it says that write a graph of g whose graph represents the indicated transformation of the graph of f of x. So our starting point is f of x equals -2 absolute value of x minus 4 plus 2. Now this is by far the hardest problem on the assignment because we have to really think. If we go back to when we first started on section 1.1, we talked about vertex form. So remember, our vertex is hk. So in this case, our vertex is at 4, 2. And this is our way the function looks. Remember, when you do vertical stretches, it gets skinnier. But if I shrink it, it gets wider. So what's happening is I have to end up, since I know what the vertex is going to end up at, the vertex ends up here at 4, 1. I might know my new function is going to look like this to get that vertex at 4, 1. And now I have to look at that and say, okay, well, I did a vertical shrink of this, which made it wider. What do I have to multiply 2 by to get to 1? And what you have to multiply that by is you divide it by 2 or multiply by 1/2. So that means I'm going to have to take this and multiply by 1/2. So 1/2 times -2 is -1, or you can just put a negative sign there. And that gives me the -1 or negative sign. And again, you don't do it to what's in the absolute value. It would get to that later once I knew what x was. But you have to go 1/2 times 2 gives you the 1. And so that's what my new function would be for my g of x. So that one was a lot more difficult than the others. So 23 says, which equation represents the transformation of the graph of f from figure A to figure B? So our graph for figure A looks something like this, and our graph for figure B looks something like this. So here's where people again get confused, as they think they reflected that, but it actually got closer to the vertex. And again, the difference in the lines is they're just stopping at the line over here, and so that's why this one's longer. Remember, these arrows mean it goes on forever. All right? So this moves to the left, so remember that would be a, we don't know what our f of x is, so they've got it y equals f of x. But we do know it moved 2 to the left, or we know it moved to the left, so it would be f of x. Since it went to the left, that would be minus, but we do the opposite, so it's going to be plus something. And we don't know what that is, but there's only one equation that has a f of x plus something, and that would be the one that says f of x plus 2. So 25. Says write an equation that represents the transformation of the graph of A to B. So again, we've just got a graph to look at, and it looks something like this, and the other one looks something like this. And so this one went up, okay? And up is vertical, and so vertical means you add the same number to both sides. So we need f of x plus something, and we only have one that has that, and that would be, in this case, 2. So if you look at 27, says write a function g whose graph represents a vertical stretch by a factor of 2 followed by a translation 1 unit up of, and our original function is f of x equals x. So remember, just take your transformations one at a time. It says a vertical stretch by a factor of 2. Vertical means we take the whole thing. Stretches and shrinks, we multiply. So 2x. And now we're going to take that and go 1 unit up. Well, again, 1 unit up would affect the whole thing. So we'd add 1, and then we simplify. 2 times x is 2x plus 1. And we're done. So 29 says write a function g whose graph represents a translation 2 units to the right followed by a horizontal stretch by a factor of 2. And our original function is f of x equals the absolute value of x. So again, we take it one at a time. It says graph represents a translation 2 units to the right. So to the right is horizontal, so it affects just the x. Right would be a plus 2. We do the opposite. So the absolute value of x minus 2. And then it says followed by a stretch by a factor of 2. So again, a horizontal stretch. So again, that just affects the x. And so we're doing a horizontal stretch of 2. Remember, it's multiplied, so you do the reciprocal. And the reciprocal of 2 is 1/2. So that would be 1/2 times x minus 2, and you're done. So let's go to 31. Says write a function whose graph represents the indicated transformations of the graph of f of x, or a graph of f. So they give us a graph that looks something like this, and then they take and they flip it over and they slide it down 8. So this graph up here is, remember, when we get the v, it's because it's absolute value. So that would be the absolute value of x. Then what they did was they flipped it over the x-axis, and so that would be vertical. So we go negative x because it affects the whole thing. And then they slid it down 8. So again, that's vertical, so it affects the whole thing. And so that would be our function. 33. Says, identify and correct the error in writing the function g whose graph represents the indicated transformation of the graph of f of x. And so they tell you that it's f of x equals the absolute value of x as our starting point. We're going to move that 3 units right. Well, 3 units right, remember, is horizontal, so it just affects the x. And it would be the opposite of what it says. So 3 to the right would be a minus 3. And then it says 2 units up, which would affect the whole thing, so we put the plus 2 on the outside. Well, what they have is they have x plus 3 plus 2. So their mistake was when they wrote it should have been x minus 3. So it should have been subtraction and not addition, so that would be the first choice. 35. It says your friend claims that when writing a function whose graph represents a combination of transformations, the order is not important. Is your friend correct? Justify your answer. Well, when it says isn't important, let's just take as an example, if we have x and we move it up 2, so that would be x plus 2, and we moved it vertical stretch of 3 followed by vertical stretch of 3, then that would be this, and we get 3x plus 2, plus 6. Whereas if I did the vertical stretch first, I'd get 3x, and then I move it up 2, I get plus 2. So the answer would be no, and you can look at that and decide which of the two no's it should be. So let's go to 37. So on this one it says, describe the transformation of the graph of f of x equals x minus 3. So this is our starting point. And then it says, describe the transformation. So if we look at the graph, it's over and then it would be over 3 to the left of the 0. So that would look like this. And they want us to find the area here. Well, the first thing is we started here and we moved 1, 2, 3, 4, 5, 6 to the left. So that would be, again, parentheses x. 6 to the left would be a plus 6. Whoops. Plus 6 minus 3. And so that would simplify into the absolute value of x plus 3. That would be the translation. So the graph has been translated 6 units to the left. And now they want you to find the area of this. Well, remember, area of a triangle is 1/2 the base times the height. The base is 6. The height is 3. So you just go 6 times 3 is 18, and half of 18 is 9. And so that would be the area in square units. The last one, 39, says, describe the transformation of f of x equals negative x plus 4. So again, we have a graph, and this crosses at 4, and this crosses at 4. And so our f of x, they say, is negative x plus 4. And then we moved it so it's down here, but it still crosses at 4. So we flipped it over the x-axis. So we multiply the whole thing. It's vertical. We multiply the whole thing by negative, so we get x minus 4, because our y-intercept is negative 4. So that would be, it's a reflection in the x-axis. And again, they want us to find this area. So from 4 to negative 4 is 8. And this is 4. So again, it's 1/2 the base times the height. 8 times 4, 32. And so the answer is 16. So hopefully this helped. Again, I'm sorry I couldn't be there. But use this to help yourself when you get stuck. So good luck. Hope you understood it. Thanks. Bye. I'm taping her.